All right, this is the ingenuity function inverses the quiz part. Let's get started. All right, so if you just swap the values of x's and y's, and then you'll be able to see that, for example, you swap the 3 and -5, so if your first point should be -5 comma 3, okay, so on and so forth. You do it for the rest of the points, your answer is going to be the second one. Okay, so if f of x is equal to y is equal to 2x plus 5, okay, so let's just focus on the y. Okay, you're gonna have to find out what's the inverse of f of x, but now we're gonna have to insert 8 into x after you find the inverse. Okay, so first of all, go ahead and swap the position of x and y. So you're gonna have x equals to 2y plus 5, and now we're gonna be isolating y. So subtract 5 on both sides. X minus 5 equals to 2y, and you divide by 2 on both sides, so you got y equals to, knowing that this is the inverse, okay, inverse of function, and then y is equal to x minus 5 over 2. Now I'm going to insert 8 into x, so which means that you have to do the same thing over here. So it's going to become 8 minus 5 over 2, so that's going to be 3/2. Check the second one. Okay, so for this next one, they're asking you that the f of x and the inverse, which point, what is the point of their intersection? Okay, so which means that whatever that your f of x has, your inverse has to have the same point. Okay, so here is the answer. So if f of x has the 3 comma 3, and then if you swap it to find out what the point that is contained by the inverse function, that's going to be 3 comma 3, because you swap it, it's still 3 comma 3. So which just tells you that 3 comma 3 is going to be the point of intersection of these two functions. Okay, so this next one, you either use the g of x subbing to the x, or vice versa, use the 5x minus 25 subbing to the second x, and then that would be the expression to verify that whether if you composite them together, these two inverse functions, if they equal to x. If they equal to x, that's how you're going to be verifying it. Okay, so let's see. If you just if you just subbing the 5x minus 25 into 1/5 into this x. So right here, 5x minus 25, and then continue to write plus 5. If this is giving you equal to x, then these two functions are going to be inverse to each other. Okay, but anyhow, this is going to be how you're verifying it. Okay, let's check this out. So f of g of x, if these two functions are inverse to each other, that's going to equal to x. So check this out right here. F of g of 2, if they're inverse to each other, that's just going to equal to 2. Okay, so if f of x and g of x are inverse function to each other, so when they composite together, if I say f of g of x is a function by itself, we call it y, we know that this has to equal to x. Okay, so the line you're looking for is y equals to x. So you're gonna have to check the second one. Okay, so let's look at the next one. So which function has an inverse that's also a function? Okay, so you're gonna look for the one that's correct. So here's the concept. For every x, you only have one y. For every x, you only got one y. Okay, so your answer is going to be the first one. Okay, so let's look at the next one. So which function whose inverse is also a function? So let me show you guys something called the horizontal line test. Okay, so if you testing out the f of x using the horizontal line test, and every horizontal line I'm drawing on the f of x only has one point of intersection. That tells you that your inverse function is going to be a function. So you're going to have to check this one. Now I'm going to show you guys the other three, how come they're not. Because check this out. Look at this horizontal line test. I have 2 points of intersection. Sorry. So it's not one-to-one. As a matter of fact, none of them are one-to-one on the right-hand side. None. Okay, so let's test out the other one. So check this out. This horizontal line test gives you 3 points of intersection. Okay, so no. Look at this last one right here. One horizontal line, you got 2 points of intersection. So don't pick these three. All right, so this is basically just the concept. So what can you use to explain the function has an inverse function that's a function. So basically this function has to pass the horizontal line test to see that whether this is a one-to-one function. Okay, if it's a one-to-one function, its inverse is also a function. Okay, so which function has the inverse that is a function? Okay, so which one would that be? So the one that can pass you with the one-to-one function is going to be the one that's linear. Okay, so let's check this out. Why? Because look at this. This is a linear. So when you're drawing it, it's going to be just a line. Okay, it's a negative. Okay, so I know it's going to be a line going with a negative slope. So that's going to help. That's going to allow you to use the horizontal line test, and then seeing that every horizontal line only has 1 point of intersect. So this is a one-to-one function. Okay, so make sure you check this one, the third one. Okay, so this last one is also the concept. So you just have to pass the horizontal line test. Okay, so that's it. Take care. Peace out.